You won't believe your mind. Can you turn the camera this way?
Can you put your, should you share your screen?
Oh, I'm not sharing my screen?
It doesn't look like it. I don't know if you've seen this, Rowan, but apparently there's an app that you can translate in real time offline?
It's Google Translate.
That's
offline, yeah.
unreal.
You just need to download the library, and then you're good to go. Okay. So you switch to this one. Oh, I don't know if it's going to pick it up.
What?
Sorry if you're not seeing this, but people are mind blown. There you go.
That's unreal. And it uses the same font.
It picks up the font, the color, it masks it,
match.
and then replace it, and it tracks
Ridiculous.
Doesn't matter. So we were at the restaurant, and it was like, okay, what are we gonna eat? You know, I don't understand. And
Yeah,
it's like, there you go. Okay.
Now you know.
This is good. Not all libraries work, but they have common Chinese like Mandarin, and then a few other. So when you travel.
Yeah, but like Spanish for sure. I'm sure. Yeah.
Yeah, totally.
That's really cool.
Which screen am I? You guys are seeing this one, right?
Yeah. Full.
Oh, swing screens.
Yeah, so there's a couple things we wanted to go over. Tom's gonna teach us about mag, and then we'll probably chat briefly about the combo objective function stuff.
Yeah. It sounds very fancy.
Combo objective function. It is very fancy. No, it's not. It's actually pretty simple. Take it away.
I guess it's because Ron started to freak out because there's so many things on that pull request. It's getting bigger and bigger, and it's like, holy shit. Yeah, it's kind of a PR that's getting out of control, but there's cool stuff. So most of it you guys have seen already, like I've presented it so many times. But it's the MVI Cartesian. Amplitude inversion, that one is the nonlinear. So now we're getting in the nonlinear part of the inversions, which is, I think, the next step for us. It's interesting, right? For this guy, I did some switches for equivalent source inversion. So inverges for layers, which is basically just a mapping, right? And then the CMI was in the thesis. And then that's because someone wanted to write a paper, Jeff Witter. Jeff? Yeah.
I don't think he can.
What's that?
He can. You were going to try to listen to you.
Oh, I see.
We can send him the link later.
Yeah. But he's working on a data set. I don't know if
Where is he? Is he in?
He's in Vancouver, yeah.
Okay.
I don't know if I'm allowed to talk about this, but this is the data set. And when he showed it to me, this is a TMI, and then obviously there's like super intense remnants, you know. This is close to Mount Baker, so it's almost vertical field. And then this is amplitude, the amplitude of the data. So we want, like when we saw that, it was like, okay, for sure, we'll need the code. So we started writing the code for Jeff. So now we have the MVI and the magnetic inversion. And then for Mira, I needed the gravity gradiometry. And then since Sagi already had written the PD mag, added the gravity in PD. And then the nice thing is that we get the gradiometry for free.
Nice.
Have you tested the accuracy of gravity gradiometry?
Yeah.
In
the paper, yeah.
Or something like that, because like he was emphasizing increasing the order because there's a second order average.
Mm-hmm.
So just like what we got from point only, there wasn't enough, so we had to increase that to a full.
Yeah.
So like, was it okay?
I mean, I haven't. That's probably important for the inversion. Right now, it's just forward. We only have the forward part of it. and I tested. I checked against the analytical, and it was good enough accuracy-wise in decimal places for my purpose. Maybe when we go to the inversions, we'll need to increase that accuracy, but
Well, I don't see why that's the problem. The core problem works, and I'm not sure why.
Because you're carrying those inaccuracy further down, right? And then you're acting on gradients of the fields.
Yeah.
Whereas in this case, I'm only interested at the field themselves. So I don't know.
Because I don't think in the inversion that accuracy stats. Because for instance, the accuracy series, when you're doing time domain for a model, and say your time stat, and then error actually propagates and gets bigger and bigger. I don't know. I wasn't sure because
yeah, I'm not sure either.
As long as you got the right core solution, then I don't see any problem for that was my feeling.
Yeah, I don't know.
Just curious.
We'll tackle the inversion, I guess, down the road.
Well, I don't know. I think I'm not sure when I was playing with the PDE mag.
Yeah.
Yeah, that mine it didn't converge here very well, so I wasn't exactly sure what was the problem. Yeah, it took a really long time to converge, and I don't know if it was a long time ago, so yeah.
Yeah.
Still not sure.
Well, we'll get back to it this month,
Yeah,
I guess.
I had some problem SP as well.
Okay.
Sometimes.
Okay.
It depends on the model. It converts really slowly.
Yeah.
Which I wasn't sure.
Which same thing for the parametric, right? The parametric mag that we were attempting with
the
Nate.
parametric one sort of makes sense. I think it doesn't.
Because the space is not very.
Yeah, what I was suspicious about how they're solving, it's this. Because I think it's a little different. Anyway, you're generating the sensitivity, and then doing JPEG and JTPEG, as we do similar way, this inexact observation types of things. But the PDE, you're not generating. It's still, I don't know. I think there is a little bit of difference, either you generate or not. So
isn't the only difference is when you're going to do the multiplication? Because it's still you're just stacking your operators rather than creating.
Well, I think the difference is are you using actually the full accurate sensitivity or not? So one the other way, we're actually using pretty poor accuracy sensitivity function. And the other way, the other one actually using the right accurate sensitivity function. So does that makes a difference? I don't know, but I was really suspicious about that. So
Perfect. Yeah, that's true.
that sounds good.
Yeah. Looking forward to start working on the Mag PDE for sure. There's a lot of open questions. And then I just wrote the examples and tests to increase the coverage, to be able to pass coverage. And then yesterday was more on the spherical formulation, which is super highly nonlinear. And then ended up now to the point where we need the composable objective functions, because everything needs to scale, differently depending of angles or amplitude. And then the tests are. As usual.
Can I ask one question?
Yeah, for sure.
Are you because are you doing the same way that handle the null space? Are you doing the same way that you did with this? Well, it's basically the same Poisson equation, so that somehow you need to deal with the null space.
For the full PDE?
Yeah. So are you doing the same thing? Just substituting one element of the A matrix, is that what you're doing?
Huh. I haven't thought of that. I just created the operator as Laplacian for the gravity, and then there's no source term. So boundary conditions is just homogeneous boundary conditions are all around. It's just zero far away.
Right.
Solve.
Okay. Interesting. So you didn't do that trick, right?
I didn't have to, but maybe we should double check. Yeah. I mean, yeah. The only thing I checked was the forward.
Okay.
So yeah, we'll have to look at it. Good. That's a good point.
Yeah, I had a couple issues when I was developing that. It's
Yeah, that's a good point.
at that time I think I didn't want to do that trick, so I had to like find the right iterative solver that I can handle the singularity. There
Yeah,
were
that's,
like some issues, so.
Yeah, I'm curious now that you're. I haven't looked at it. I know. Sure. Where the heck? That's the linear. Differential.
Can you zoom in a bit?
Can I do this? So that's just the mass matrix. And then,
Yeah.
Yeah.
I think it's in the
Right.
problem class. The cellular and visual. Okay, so in that case, you don't need any boundary. Well, like if you're not using one.
Right, because Dirichlet fixes the boundary conditions.
Usually it was no.
Yeah.
right.
Yeah, actually, maybe from. Well, like that, is it your potential is zero or
Yeah.
your field is zero?
Yeah,
Right.
For gravity, actually, that might be gravity.
I'm not sure. Yeah.
Gravitational.
No, the potential should be continuous, like to infinity. It shouldn't be zero.
Yeah, I don't know. I'm not sure. Well, but like what you're doing is like I don't care about backgrounds with like having some sort of isolated part.
Yes, that's true.
Like, is that potential is zero if your boundary is far enough? Fine. Yeah, decay is different. Okay.
How much do you have to have?
Good
On a
question. Huh?
gravity problem?
I mean, if I ask you, like, how many times I would have, if you.
So for my problem, I just tested it. I just like kept increasing paddings until eventually my fields were changing to the decimal places that I didn't care about, and then that's good enough. Then I would just apply that same mesh everywhere. If you with one mesh, I was just like recycling it.
That's how I test it. I did it most.
Yeah. So it was more in terms of like how big my values were and how much like inaccuracy I'm willing to take. I don't have an answer for that. Yeah.
Cool, and that's a good enough answer. I mean, that's a really important answer. I mean, because once you start to add like adding cells, you're adding. I mean, you're wasting resources on something that you don't care about.
It's trade-off.
You feel
Yeah.
more effectively,
For sure.
useful.
So yeah. More work to be done. Then there's no derivatives right now, which derivatives will be very straightforward.
Yeah.
It's linear. What else do I want to? Oh, maybe just run the example. So now I'm sure, right? Coverage looks at examples to not just the test, but the examples too.
Yeah.
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 And yeah, since most of them it's like inversion related, I'm covering with examples because I know that I'm touching everything. It's probably not the best way to do it.
No, examples are actually fantastic. And because when I was doing the this combo regularization stuff, that was the only way I actually knew things were working because it would run, right?
Yeah, but
I could tell that I didn't break
with
your
the
sparse with the pictures.
But then
So-
we don't have like something that says, oh,
Yeah.
that result is just like the linear inverse, right?
Yeah, yeah.
It's like, oh, it runs.
Yeah.
But
but is it reasonable?
yeah, exactly.
That's fair.
Okay, where am I here? Am I on the right bench?
Oh, you might be on the objective function stuff because we switched to that.
Oh yeah, that's why. Oh, so you pulled recently because you had the gravity in yours.
Yeah, it should be up to date with dev.
Okay, perfect. So here's an example. What's the most important part for the nonlinear inversions? Are the directives. Sorry.
Your dumb stuff. I went over the.
Hi.
Do you know Finneker?
I think both of them. Yeah, that's probably, that would make sense.
Exactly.
Econometrics, yeah.
No, let's meet you.
I'm Greg.
Just FYI, we're recording this. Just, there are some people who aren't able to do their chips, you know.
Thank you.
Yeah, no worries.
Yeah, I was just saying for the nonlinear problems, the important part is the directive to update between each iteration. Or like I think eventually I want to make examples and we start talking about it as a group because at least for the nonlinear problems attached, you definitely need to reweight your sensitivity every time you change a model. Functions are changing as we go. For the amplitude inversion, it depends on the data. So the approximate sensitivity, sorry here, for the amplitude problem, it changes as a function of the data. For the NVI spherical, it changes as a function of the model. But in either case, J transpose J is iteration dependent. And if we don't do that, I'll create an example to show you what happens in both cases. But if you don't update often enough, you end up with in a weird space.
And so for your regularization, you're updating all your cell weights in the same way, though. You're applying the same cell weights. Is that true?
Sorry, can you repeat that?
Okay, so in your regularization, when you update the cell weights, you want to update those on like your smallness term, your smoothness term.
Correct. Yeah, for
Okay.
sensitivities, it's taking, the entire regularization is taking all the weights.
Okay.
There's a special case for the spherical. Model parameters are the same.
Right.
Two of them are angles. One of them is a model value.
Right.
So you can't treat them the same way. So you need also to compensate for it. But that's another level of complexity. That's why the composable objective function is important, because I need to touch those different blocks differently.
Right.
I cannot just apply blankly on everything. Anyways, this is the outcome of so this is a susceptibility inversion. You guys have seen that before, using the wrong assumption. And then you end up with stuff at the wrong place. But if you do an amplitude inversion, things end up at the right place. That's just,
so sorry, by the wrong assumption, you're not applying.
so here I magnetize my block at 45 degrees like
Yep.
this, and but I'm assuming a vertical inducing.
Okay.
So it has to create that negative lobe. It needs to put stuff on either side. Or when we run that example, it created like stuff like on the wrong places, and it's actually a dike that runs right in the middle here. So that's why amplitude is important. And then finally, what managed to work last night is is a spherical NVI and spherical. I guess I can show you also example for Cartesian. It's again the same block. Cartesian is the same as, the only difference is right now I'm using Soggy's stacked objective function, which works, but it gets very complicated because everything needs to be accessed, and So that's where Lindsay, when we're gonna switch to global, it's gonna be much clearer what's happening. And then this is MBI and Cartesian. Where am I? MBI and Cartesian. So this is where the orientation of magnetization. And then MBI and Cartesian is not great by itself because there's too much non-uniqueness, and then you end up with like weird shapes like this, you know.
Because in that case, you're actually.
I'm solving for three times model parameters.
Okay, but you're regularizing. In a sense, you're like favoring things that are axis aligned. Is that true?
That there are what, sorry?
That are axis aligned with your regularization?
No.
Sort of?
Well, you're still in this Cartesian group, so.
You're favoring vectors that are all the same. Does that make sense?
I guess what's your reference model in this case?
It's still 0 because
Okay.
in this case you're going for the smallest model, but on X, Y, and Z independently.
Yeah.
So whichever is easiest to create a model is gonna go towards there. And in this case, it's just easier to create two anomalies because you have kind of like a double lobe.
Yeah.
So it will put stuff on either side. But if you solve in spherical, then things are a little bit different. There's still some like.
So like all the alpha values and stuff like that.
All the same, even alpha s, right? Because we removed the dimensionality. Yeah. So the goal is to do better than this guy by imposing sparsity. But if you guys remember, we cannot do sparsity on the Cartesian formulation because you end up with things that are polarized along X, Y, or Z.
Yeah.
Right.
So that's why the spherical formulation.
I think that's clear what this is point for us, because that actually are original bias that your smoothing is actually along X.
If you do sparsity, yes, you're right. Yeah.
Yeah,
For smoothness, it's just smoothness.
that's fair.
Yeah. We're not doing cross smoothness though. We're not looking. That's one thing that we could have tried is to look at smoothness across your three spaces, across the X, Y, and Z
Okay.
space.
Yeah.
The difference is like
Yeah.
you're considering this like style.
So instead of being a block diag, it would be a lot of off diags. Yeah, exactly. And that's the difference with the. Oops. Oh, it's showing on my screen. I guess I changed my colors. It's not nice, but this is the Cartesian formulation. You have like a double lobe here, but then when you go to circle, it's just a simpler space.
Okay.
And now we're starting to get stuff that just much more like a mag inversion. Start putting compactness on them. That's the idea. I'm not there yet. I have a lot of problems with the line search. It keeps breaking on me.
Yeah.
I'm not entirely sure.
Yeah, I think that we should actually look at this is probably the right time to
Review.
actually what the BFGS does, and then like we should try a couple of different things. I think that was it's a great like it's working, but sometimes like
I just don't know why it breaks.
yeah. So I wasn't exactly sure because like those are like sort of like for me still it's like a black box because
Yeah.
I don't understand and then,
Yeah.
yeah, so we probably need to add a little bit more options and then actually test for not in your case.
But I'll be honest with you, even if it's breaking and I don't know why, compared to my MATLAB, what I had written in MATLAB, the model looks a lot better. I don't know why. It looks a lot better. But then it breaks on me, and I have no idea how to push it. How to force
Well,
it.
you can make it go.
Yeah, I force it through the true statement, but then then you go into some weird spaces.
Now you're right? Like, this is
Sure.
not decrease.
Yeah, I've tried that. Yeah, it doesn't work.
But isn't that kind of in the pipeline to kind of go and have a look at the regularization?
Yeah, so the regularization is pretty close with the combo stuff. Dom and I were going through it this morning. There's a couple little bugs that need to be ironed out.
Yeah.
But then the reviewing like the optimization code does need to, that needs to happen. Yeah.
That's, I guess, probably the one thing that hasn't.
Yeah, it hasn't
Worked
been
on.
like really hit on since it was started. So, yeah. Yeah, so especially like if now that there's examples of things that like should work, but we're running into issues, I think that that helps.
Yeah, it seems like still there is some randomness in how we're like actually doing it. So
Randomness in,
Like you start two inversions and yeah.
because I think that, for instance, like how we're solving this like, JP and JT back and then like pulling that up for solving Asian is there are like because
That shouldn't though. I mean,
yeah I don't know but like is that was one thing I was like pushing hard. I wanted to make this example solid.
and then it
And
keeps
then
on changing.
and then I actually like not make solid, right? I cannot get exactly the same result.
really, it's actually, and are you using anything to like estimate betas?
no.
You're
I was
fixing
fixing
beta.
beta. Actually, have you like if you try, if you fix the beta and then
Yeah.
like fix some seed and everything,
Yeah.
still
You're still
you'll
not
get
getting the
different
same result.
result. So yeah, so I don't know. Like there's something, some part, and there's
Somewhere.
some randomness going on. And,
Yeah, that's worth looking at because I don't know where that would come in.
We'll have to go down the chain. Yeah. Although the linear inversion that we were talking last meeting, yeah, that one is pretty consistent every time. So it
Can
might
you get exact same value?
values like to the decimal places.
Okay.
Well, let's try it. I mean, there we go.
That would also be worth like generating some tests where we are expecting a single or like some fixed values out of it.
Yeah, because I don't know. It's although it's a nonlinear inversion.
Yeah.
If you use exactly the same value and exactly the same function sensitivity, then your output should get exactly the same.
Yeah.
So
Yeah.
uh,
Yeah. I would agree with that statement.
Crap, it doesn't keep it there. 1 sec.
Yeah. It's still.
No, but it's not gonna save the.
Oh, the answers.
Which one is it? Yeah, 2 different softwares. See what happens. I guess we'll wait for the end. Slower. Spider is slow. Let's see. Yeah, exact same numbers.
okay. That's good.
So that one is stable. It's stable on my machine, not on your machine though.
That's fine.
It's machine dependent, which we haven't.
I think because I was making. I hope that I can make the exactly same result for SimPEG paper.
Yeah.
That was the time I was getting involved. I was using time domain instead.
For inversion.
Yeah. Yeah, sort of a similar result, but not exactly the same result.
Wrote the paper, or now you're trying to get it like if you run it twice in a row,
Yeah, but non-trust.
you get slightly different results.
Well, sometimes like
Huh.
quite different. No, like the main trend doesn't change. But
Okay.
And before I finish, I just want to show Lindsay how the method looks right now. Yours going to look. You see now everything I needed to create a list of alphas, right? Lists of everything. And every time I was creating my thing, I needed to loop through a n space of and then stack my objective function.
Okay, yeah.
So now
We
it's
can
going to be
fix
much
that.
cleaner. Yeah.
Yeah, what we're working on doing is like the next big push that's coming within the objective functions and regularization is we're trying to make it so that it's easier to compose your objective functions. So to do joint inversions or things like that, like I can add a regularization on sigma and a regularization on mu together.
So you can build your own
Yeah.
objective function.
Yeah.
So that sounds nice.
Yeah, so hopefully by the end of the week we can have like a version that you can play with. And you can yell when it breaks. Because, yeah, that's how that works.
And then I'm almost passing something.
Oh, you can try rerunning that.
What's happening? Do you see it?
Sometimes it stalls on the installation.
Okay, well, whatever. One thing, Sug, for some reason, this guy has the you remember, like I need it, I'm using it, but it's in the maps. This guy mesh topo
Oh, I actually commented out.
as well. Yeah.
But do you need that?
Yeah, I'm using it for a project. Yeah.
Yeah, so I can have it. They're probably, yeah, I think that's actually like how they test the maps. So.
Yeah, that's where it failed. Yeah.
Yeah, if you didn't add like a couple of stuff, like I don't know, there's a 2D statement, a 3D statement. So,
If you want to pull up the test, I can show you
yeah. it's a problem.
where it's doing that. Oh,
Oh,
sorry,
sorry. Yeah,
the test code.
Gotcha.
Yeah, so what it does, because most maps are very simple in that all you need to instantiate them is a mesh. And so in this case, anything that's not in this list, it's going to try to create the map and run a test on it. But in this case, because the mesh-to-mesh topo, I think you need to give it a couple other parameters.
Right.
Probably it'll fail.
Fail.
Did I put the 2D? Because I didn't, I guess. Like, it may also.
It's just for
Oh, it might only be 3D. Okay.
So like first thing you may need to do, like put your like that map to excluding 2D.
I see.
Then that may work.
I'll let you do it. But yeah, if you can bring it down, I won't have to comment it in and out every time I need it.
That sounds good.
Yeah, when I was pushing it, I just commented that. So
You should translate a mesh to another.
Just the topo layer, I believe.
yeah, well, like it takes care of because you have a like global mesh, just off, and you have a local mesh. You project it. Yeah, from global to local mesh, considering.
Yes, that's right. That's
You
right.
need to both like air cells, this mesh.
And Soggy, is that for the case like where you're doing SP, where you're basically just like cutting off your domain?
No,
No.
I think this was for actually like a domain condition. So.
Like when you tile.
Oh, okay.
So I actually made an example.
Yeah.
A long time ago. Making underneath formal names like hundreds of mesh, global mesh, break apart.
Yeah.
But that's probably so.
Oh, okay. You need to be
Go back and
careful.
forth.
Yeah.
So, yeah, so I think it did work okay. I was using
KD3 is great. Yeah.
KD3 is pretty fast.
And then the nice thing about like once it generates all the trees and then actually like generating finding all the like the neighboring cells.
Okay.
So,
Nice.
Your topo layer is also was very important. This was a nice contribution. Your surface to end
yeah.
just to get that layer. Because that then for the equivalent source, that was just a mapping. Right? I was just calling your function. Function is just, sorry, am I the right place? This gets used. What? I'm missing my mind. Where is it? Yeah, it's just a reduced face on that surface, and then you just invert with that surface, that layer.
I took somebody else's code and adapted it.
Okay.
So
Oh,
it was
okay.
the original one.
It's bouncing in, bouncing in.
There you go.
All right, that's it for me.
Cool. Thanks, John.
That's good.
That's really cool.
So it will be combo, and then also changing the survey from EM. Well, we were talking about it yesterday. You're not convinced that it's necessary, but
And then, yeah, so like, because like it's actually saying the CC problem, a mobile problem, basically saying, and yeah, like 5JE, they have all the corresponding components in this.
exactly.
Can make a charge as well.
Yeah, gravity
That
charge.
actually- yeah.
Charge, I don't know what it is.
It's, that's not the Higgs particle. Cool.
Cool. Yeah, I'll try to get the combo stuff up and running and maybe grab an example or try and make a simple example.
Yeah, I was thinking about it. I might, yeah. What's a simple example? Can we do a linear that has two different model spaces?
Can we just do that and
That's a complicated one, Rowan. Rowan's suggesting mu and sigma from EM. I mean, we could try it, but it is,
well, I think not a bad idea.
it's not a bad idea. Because we do
Well,
actually
why
have
don't
the
we do
pieces.
frequency domain.
Yeah, we could try that.
Similar to coordinates.
Actually, yeah, that should be
And then
okay.
I think it's a little bit of color.
Yeah, and do a 1D.
Yeah, 1D.
Yeah.
Like the easy.
Okay, sure, Rowan. Yeah.
That was me, Ron.
Cool.
Do you think you will change your version much, or if you write the example
If I write the example for,
example for combo objective function, you'll be changing it, or
it shouldn't be too complicated, actually. Yeah, it should be just as simple as changing the regularization, in theory.
okay,
So if we've done everything right, it should be that simple.
sounds good. Well, I'm not gonna wait. I'll try it.
Yeah.
How are you? So what is it like for this case, your problem is one?
Yeah.
One problem.
Yeah.
But there are multiple physical problems.
Yeah.
And your phi n has like different phi for sigma and e, is that?
Yeah, so in this case, all I would do for that problem is construct. We have a single phi d, and then my regularization just consists of a phi sigma and a phi mu, and I'll just add them together. And they could both be Tikhonov, they can be whatever, and just weight them relative to one another.
Yeah, I see. That sounds good.
Yeah, so it should be pretty straightforward, hopefully.
Yeah, I think so. I can help out.
Okay, that sounds good. I'll try, there's a couple issues, because one of the things we want to make sure is that the regularization is actually like nested in a sense. And so that wasn't properly implemented yet. So that basically what I can do is add together multiple objective functions and call that one thing. So Tikhonov is really just smallness plus smoothness, right? Group those things and call that my sigma regularization. And then do the same thing for mu, and then treat those as like one thing each, but really they're composed of multiple things.
So you have a phi sigma and phi mu for regularization.
Yeah.
And below that, there's this particular style.
Yeah.
That sounds.
Okay. Yeah, hopefully I'll get that fixed today even, and then we can play with it.
Yeah. I'll implement an ag right away, and then I might have to tweak what we're talking about. Just move the operator. Where were we? Oh, did you change it already? Oh no, yes, it's different place, but move the operator, the gradient operator, outside of the weights. So weights are one thing, and then f of m is something else.
Yeah.
Yeah.
Cool. And then the other thing, hopefully coming in today or tomorrow, I've now got the time domain EBHJ all running.
Isn't it running?
Not HJ.
Oh, HJ.
Yeah. So, and then there's a couple things that, like I don't have, they're not all cross compatible yet. Like you can't get H from EB yet, but that can come later on.
I was using that, and it seems like there's, I don't know, look at the code that we found, but these are from EB for
Yeah.
B field, it didn't look good.
Right. And so what I did there, so from B, the magnetic field, so if you solve B, you can get E, you can get B, and you can get dB dt.
Sure.
If you solve for E, you can only get E and dB dt, the way I've implemented it right now. Because B, to actually get the exact same result as what you would get in the other system, you actually have to solve another PDE.
Is that the initial condition, or?
No, it doesn't just naturally actually eliminate, because the thing that you eliminate to get E formulation is you eliminate dB dt. So you can naturally get that out. But B, you can either like you can integrate, which that was what I was doing, but you're not going to get the exact same results as doing the other formulation. Like it is better just to, if you want B, you should just solve for B.
Okay.
Right.
So that's how that's implemented right now. Just to keep it simple, we can chat about if we want to actually, what we want to do about that.
Do you have a brief idea what, let's say, because it's a little bit annoying, say, now you got the seekers,
Yeah.
which is electrical field and magnetic field.
Yeah.
And then somehow, there's a problem. Then, it's kind of annoying that you need to solve like a two problem to do that, or?
No, you can solve problem B to get all those things.
Yeah, sure, right, but
If you want to solve E, we need to, sure. If you want to solve E, we need to talk about like how you want to do that. Because sure, we could integrate, but that's not going to be the same accuracy if you had solved the other problem.
Yeah. Okay.
Yeah, that or we can.
That integration, not too bad, but
it's not too bad, but you're not going to get the exact same result. So they're not like strictly.
Yeah. Okay. Yeah, but what I thought that there are a couple of missing parts. Like for instance, your initial state, because to get all the way back to the B field,
Yeah.
you need the previous time.
Yeah.
So, but like the one missing part, when you were doing, I think, you didn't have, you didn't compute the enough and then integrate over. That was like, it's like your research, I thought the research, and
It was fishing.
Just not.
Well, because all I did was just do like a simple, like rectangle integration. So you just needed the previous time step. So it wasn't very high order.
But my question is like, because when you're solving E,
Yeah.
first compute initial condition of E.
Yeah.
Right? And
Yeah.
that's that.
Yeah.
Okay. But like, are you actually going initial condition of E and then integrate, or like the initial condition is missing? That's my question.
When you're solving problem E.
E, problem E. Because like to get, like my point is to get the B, you
Yeah.
need this integration, right?
Right.
And then you need the previous time channel of B.
Yeah.
Right? So even for first time, to get the first time channel of B.
Yeah.
And then my question was like,
Was I actually computing it?
Yeah.
Probably not.
So
Yeah. So
I
that.
think if you do that, I think that reserve may not be that too bad. Like it's
Yeah.
still
Yeah.
an okay reserve, I guess.
Okay.
That was my guess.
Yeah. No, that's something we can look at. Like this first iteration won't have that, but we can try to pull that in later on. And then Rowan just mentioned that, okay, so the discretize package that is now under the SimPEG organization, eventually that's going to be used to pull out the mesh class. So that code will get removed.
Sorry,
fairly
what did you
soon.
talk about? Discretize as well?
So there's a package called discretize that basically just is simpeg.mesh.
Oh, okay.
So we'll just use that. That'll simplify testing and things like that.
Oh, and so this guy is going to get out.
Yeah.
Okay.
But you'll still be able to interact with it
Yeah,
basically the same.
Yeah.
And then
There will be a syntax mesh.
there will be a
Yeah,
simpeg.mesh.
what's the plan for like a mesh utilities? Because where does it lead?
That's a good question. I think it depends. Depends on what you want to do. I mean, I think utils just needs an overhaul. So right now, what I would guess the first thing that we'll do is basically just leave them in SimPEG for now. And then when we see things that are actually sort of useful just on the mesh, we'll just pull it over. So
Yeah, it's,
that would be, yeah.
Because it's like sort of tangled.
Yeah.
I mean, the utils are.
yeah, it's a bit
Yeah.
of a, it's so hard to find stuff
Yeah,
sometimes.
yeah.
Well, you can do a search, but
Yeah.
it would be nice if they were organized.
Yeah, that's fair.
Yeah, and I was like introducing SimPEG to Nissan.
Oh, yeah.
He asked like he said, can help, and yeah, he was asking like make a video, YouTube video or something like that. I wasn't sure. I'm not like actually like watching YouTube video and learning stuff.
Yeah.
Like, it's actually like because we got the tutorials and then got the web page, but still people
Yeah.
are having a hard time.
Yeah.
It's how to start.
Yeah.
Where do we do that? And you need to think about what is like a sort of effective way to actually introduce this package to somebody who doesn't actually even know what SAM is.
Yeah.
My experience here is because I'm relatively new to Python. The last 10 years I've been everything in that. And so I'm just on the very beginning of learning Python, this whole package. But the way I've learned any is through the examples. Working through them because
You see running
it's out
code.
there. I know what's there and figure it
Yeah.
out. I can go step by step, figure out what are the outputs, what's going in here, what's something.
Yeah.
So that's my experience, examples.
And you're not the only one. Yeah, Jeff, Craig, all these guys. They're pretty like a high level coding, not like they're pretty new Python. And then I have an example, that's for sure.
I mean, the biggest hurdle is sign it off on.
On their machine.
Exactly.
Yeah, the installer is
Once you're there,
still rough.
Yeah.
like it's been pointed out to me like several times. The last couple of weeks, I don't have any interest in going.
Right.
There's no way this documentation. I mean, in theory, we should just go and get on that. But I think there is a bit of a generational, and that's going to be interesting with YouTube.
Yeah.
I would necessarily go
right, actually, okay, so here's my question.
Yeah.
Someone asked me, I want to install SimPEG, I want
Yeah.
to start to use, where do I stop?
Yeah.
That's the question that I thought. Then,
That's not a good answer.
sometimes, like,
Blank.
I'm a little bit like, pause,
Yeah.
like, okay, that's like a question, and then I don't actually exactly know, but what I usually do is, I don't know, I think, well, easy way, can you try to install?
Yeah.
And, but most of the people actually who ask me, like someone who could sort of develop and then like actually, probably better to use GitHub, and then, so I
Yeah.
usually go the other way, and then especially if you like start to use like kind of solvers and those kind of things,
Yeah.
it gets more complicated. But I think having that setup is important.
Yeah.
To actually start to use, because like you may want to run a little bit like relatively big speed problem for your actual problem.
Yeah.
So yeah, having like Windows especially, like say you need to set in like
Yeah.
variables and like complicated.
Well, the pip install will be fixed with discretize, because a lot of the stuff that was causing issues with Windows was this Python code, and actually that, like, we want SimPEG will be purely Python once we pull the mesh out. And then Joe fixed how to install discretize on Windows. He was able to get that like cleanly working.
Nice.
So that actually that'll hopefully remove that overhead completely. So people will be able to like pip install SimPEG, and that will reliably work.
Does it? I forgot. Does it take care of the Windows variable, environment variables? Does it map SimPEG at the right place?
If you have Anaconda
It should.
installed
Yeah.
and you pip install it, it should.
Okay. Okay.
Yeah.
Well, because it's but what makes it a little bit of an issue, because like if you go that way, then well, if you're keep updating stuff, then that's totally fine.
Yeah. If people want to switch branch.
Yeah, if you want to do something like relatively latest things, and then you need to actually need to start with that.
Yeah.
And,
There are the tutorials. So I think I actually wrote up.
Yeah, you had.
There is like a rough write-up on how to get up and running with GitHub. Yeah, there is a getting started for developers that should actually walk you through it reasonably clearly.
That is actually a pretty good resource, but I kind of agree with you said, it's not like you can't really tell anybody to go there.
Yeah.
You kind of need to know, I mean, if they know Git, yeah, just go there, you figure it out. But it's kind of like the initial, so I think with Git, like I will be
Yeah.
super.
Yeah.
I mean, once it matures a little bit and we have more of it down into
Yeah.
mastery.
One of the other things is I'm going to try and get a couple examples deployed on the Microsoft Azure system. And that's great, because then you can actually just, we have control over the install. So then people can just start using it. And don't, because then you can play with it and realize that like, this is actually useful, and then fight with it on your own machine, rather than
It's a hook.
fighting first. Yeah.
Yeah, and I mean, I think, at least with people that I've been interacting with, yeah. I mean, it's no problem for me to sit down with him for an hour and figure out
Yeah.
stuff.
But it's not good for
I mean,
you.
I had to do it for like every single computer.
Yeah.
Average stack. But I've just been asking him to kind of keep track of what it was that was useful for him.
Yeah.
And what he needed to do, just so that we can document that. Because,
Totally.
like, that is really important.
Yeah. Another thing we could do too is like, as you're introducing people, if they're comfortable, like just screencast you teaching them how to get the install going.
That's an idea.
Because then it's
We'll
like
capture
you're
it.
doing it in conversation. It's not something that we're just making up.
Right, actually, that's a good idea.
So
Yeah, just upload that as a tutorial.
Yeah.
Capture the bugs.
yeah, exactly.
Um,
But I guess kind of on that note, we have we kind of need to figure out a way for people to have an easier way to ask questions.
Yeah.
Because I mean, I love Slack. I really enjoy using Slack, but I can see, I mean, that's what people tell me. It's intimidating for them to want to kind of jump onto Slack and kind of start asking questions about why isn't it working on Windows?
Yeah.
Well, so I usually get like personal questions, even with the Slack.
Yeah.
Yeah. Someone asks me directly.
Yeah.
Not on big channel.
Yeah. Rowan's comment, and like Jupyter does this, and a few packages do this. They've got like a Google group that just is going. That's one thing we could try.
Can we add I don't know how hard it is on their website, just like a message comment box, and then people can leave, like contact me. I would like.
Yeah,
to
there is. There actually is one. Oh, Rowan just created a form. That's great. Yeah, there is on the SimPEG website. There is a way to get a hold of the person, and that goes immediately to Rowan. So the contact.
Okay.
This goes to Rowan.
I was thinking more like a message board almost type of thing.
Yeah.
But I mean, that's kind of
That's Google Groups. Yeah.
True.
Like it's kind of like a water thread.
Yeah.
You can kind of follow different searches very easily.
Yeah.
And you can kind of like read comments and so it's kind of like that.
Okay. Then we should
Yeah,
probably.
this is actually something like fine, like that.
Yeah, it is. It's, I mean, a lot of, because I mean, I used to be and they have a post, they have an email list. So it's like you're searching through your email list of person.
Yeah.
Which, yeah, it's not a bad thing, but it's
Can
something to
take
do with
the
technology.
Yeah. Cool. Okay.
Nice.
Are there any other things you guys want to go over? No? Perfect. Thanks, John. Cool. See you, Ron.
Where are you working on this